Hi guys, welcome to the Binance Africa YouTube channel. Welcome to the Web3 with Binance video series. The video tutorial series is actually, tailored to help you understand, more about Web3 and the blockchain. If this kind of content is of interest, so make sure to subscribe and enable notifications so you get alerted whenever we drop awesome content in this series. Okay. Today our topic will be on blockchain. So we'll be talking about what the blockchain is all about. Okay, like basic but yet high level concepts of how things actually work in blockchain technology. Okay, so they can be able to understand the whole process. First of all, let's kind of introduce the blockchain technology. So at its core, okay, and blockchain is basically a distributed ledger that is actually used to store information. So that's what it means on the basic level. But it's also important to keep in mind that not every distributed ledger is actually a blockchain. Okay, let me take for example, you can't take your Google Docs, as a blockchain. Okay, so yes, it's distributed. It can be distributed across a number of people, but it doesn't actually make it a blockchain, because for technology to become a blockchain technology, it has to be governed by three main rules. Okay, so one is that data can be added and it cannot be removed or modified. And then each piece of data must point back to the previous piece. That's what we call it, a blockchain, like a chain. Okay, one linking to the previous, and the new one is going to be linking to that one. Okay, so that it can be able to reference back to the very first information that was added in that particular blockchain. Okay, so this is what actually makes the blockchain technology very, very unique. Okay, so now why is this tamper proof database so important? Yes, you might be asking, what's actually the need to have like this system, this decentralized system of ledger for storing information? So it all boils down to one word: trust. You could create something where people, a group of people, many people can actually put in information. What is actually the trust in that, especially in something that's meant to actually store information which people can take as credible? Okay, usually in the Web2 space, we had centralized bodies do that for us, and then the trust is basically with the body, so that people actually trust these bodies to actually know what they're doing, to actually put the right information in there. But with Web3, which is basically trying to kind of do less of centralized bodies, there has to be a way of promoting trust, okay, to make sure that the credible information is being added to these blockchains. Okay, that's why it's hard to be like a peer-to-peer system with no central authority. But at the same time, to validate trust, it had to be visible to everybody. Okay, so there had to be a single source of truth which is still yet available to everyone, so that basically everyone have like their own copy of the blockchain. So, and that's basically how the blockchain works, and that's why these blocks are actually verified by a lot of people, a lot of nodes, we call them nodes, so that once it's actually verified, it's actually credible, like this is the right information, so that once it goes in there, it doesn't actually get removed, modified. This actually makes it credible. Okay, and then removes any incident of counterfeiting or something like that. So now let's talk about the implications of this distributed network. It means that the system is going to be secure. Okay, these distributed network, a blockchain can have 10,000 of pairs. Okay, so this pairs means 10, this will mean 10,000 people on nodes or whatever you want to call it. So that means no single person has the responsibility of keeping this data safe. Okay, just like in decentralized bodies. Okay, so everyone has this scope. So one person moving out of the block doesn't actually change anything, because there's still a lot of other people who actually have copies of that. Okay, the information is basically accessible to every other person. Okay, so another thing it implies is that is immutable. Okay, that means once, like I said, once a block is added to the chain, it can't be removed or modified. It's permanent. And then that's why there are a lot of algorithms in place, a lot of verifications before a block is even added to a blockchain in the first place. Okay, because once it gets once it gets added to the blockchain, that's it. There's no actually going back or removing or modifications. Okay, and now this actually makes it very trustworthy. So it's working on a trustless and transparent system. Okay, there's no getting this information from people, everyone, and it can be verified by anyone in anywhere around the world. So that's basically what the blockchain means. So now let's look at the brief history of blockchain. So the concept of blockchain came, as early as, the early 90s. Okay. So we've had a lot of people, come up with this idea of, this distributed ledger, okay, that is decentralized, by the way. So what we've basically been having over the years, were basically, modifications, okay? That's a very important part of whatever technology, okay? The first airplanes, the model of airplanes we have now, when, what airplanes used to be when they were actually invented, okay? So technology actually advances. That's the key point to note here. For a technology like blockchain, we are very much still early, okay? But then over these years, there have been advancements. We found out that, there are a lot of things we can do with this technology. A lot of people like, Satoshi, Vitalik, who has actually, brought in Ethereum and smart contracts. For the time to come, is going to keep advancing. That's what technologies do. Technologies advance. Okay. So that's basic, the basic timeline of the blockchain, so that that it's not something I just started yesterday. It's been the concept, the idea has been here, pretty much since the 90s. And now down to the Ethereum, smart contracts, which was actually brought on by Vitalik Buterin. Okay, so smart contracts are basically programs or scripts that are actually stored, deployed and executed on a blockchain, like let's say the Ethereum blockchain. So if you want like a system or something to happen, let's say if a transaction like this happens, sent to this address, what basic codes mean, like they give systems, instructions to follow. It's just a way of human beings actually interacting with networks and systems and computers. So that's basically what Vitalik and his Ethereum actually brought to the blockchain technology. Okay, and it's a very great one, because right now we've seen a lot of apps, dApps being introduced into the Web3 space, and that's actually good for innovation. Okay, so now let's look at how blockchain works. Now with banks, with centralized bodies, you have like private or organization actually managing data on your behalf. So when you make transactions, the banks actually actually verify these transactions and even store this data for you. Okay, so you're basically acting out of trust you have for them, to make sure that they're actually giving the right information, storing the right information, and making the right transactions, okay, on your behalf. Okay, so that's basically how centralized bodies work. Okay, they actually validate this transaction in private, so there's no need for them to actually publicize this. Okay, so they actually do it in private on the behalf of their clients. But with a blockchain, is a public database. Everyone actually verifies this. Everyone has access to it. The blockchain is there. Anyone can actually go and have access, and even look at each singular transaction, even date back to the first transaction, because of how the nature of the blockchain, blocks being tied to one another. Okay, so it's very, very easy to see everything just in one place. Okay, so that's basically the major difference between decentralized systems and most of our blockchain technology. Now that distributed and decentralized natures actually what actually makes them very, very different from the traditional ways of storing data or handling data. So let's talk about the cryptographic nature of blockchains. Okay, so we're going to talk about encryption. A lot of people get spooked, at the word. It looks too technical. It looks like you must be into cybersecurity to understand what encryption is all about. But encryption is basically translating data into codes. Okay, so when we say you want to encrypt something, it means you're changing that information to codes. Okay, meaning only a specialized system or a specialized person can actually get that code. So when we say your calls are like end-to-end encrypted, or whatever is end-to-end encrypted, it means once it's going out from you is encrypted, and only the person actually, or the system actually receiving that information, can be able to decrypt that code. Decrypt means taking it back from codes to data. So when we say encrypt means changing data to code, and decrypt means changing it from code back to normal data, the normal data it contains. So that's basically what encryption means. Okay, so for there are two types of encryptions in cryptography. We have the symmetric encryptions, and we have the asymmetric encryption. So for the symmetric encryption, there's a use of one key. That key is actually used to both encrypt and decrypt. It means the one key must be kept secured, okay, from third parties, because having one key, once someone has that key, they can be able to do anything they want with it. Okay, and that is why the asymmetric encryption, brings, an even better, advantage. Okay. So because in this case, there are actually two keys. Okay. So you have the private key, which is actually private, and you have the public key, which you can actually share with people. Okay. In this case, your private key is something you have to keep to yourself. Okay. And the public key is the one you literally don't, need to be scared of, sharing out, because these are the things, maybe people will need to use to send you, this information. Okay. Let me use, for example, your account number. So the equivalent of that in the blockchain space is your wallet address. So your wallet address in this case is basically, your crypto wallet address is basically your public key. You can share that with people. They can send you cryptocurrencies with it. But the private keys, like, your seed wallet phrase and all that, must be kept to you and to you alone. Having two keys actually helps you, it actually helps you not go back to the symmetric case where you're afraid of sharing one key, where you have one key. Having access to that one key gives access to what you would have done in the case of asymmetric encryption, where you have both keys. So separating this actually helps you, secure your account, secure your information, secure your data, while also, not being afraid to share, necessary details that people need to be able to interact, with you, okay, or with your system. So in this case, both keys are linked, okay. So it's basically linked to what is a crypto wallet. It's just that one is something you can share out, and the other is something that could be, that must, not actually could, that must, be private to you and to you alone. So now let's talk about, okay, how the asymmetric keys work. There are actually two keys, public keys, and the public key and the private key. Now the private key is what you use for signing, transactions, signing algorithms. Okay. So to actually confirm the if you're actually the one making the transactions, to actually confirm these transactions, you would need to sign this transaction. Okay. You need to sign the blockchain. Okay. So you do that with the use of your private keys. But the public keys is what, like I said, what you can send out to you, like your wallet address, which people can actually use in, sending you whatever data they want to send you. Okay. So that's basically it. Now let's look at, blockchain use cases and their limitations. Yes, and there could be some limitations, but to understand this, you need to understand, the applications where blockchains even apply in the first place. The most predominant one is for remittances. That's for sending money across. Okay, that's, the most popular use case of the blockchain technology. So that when people make transactions, is actually verified and it can be falsified. Okay, so that's one of the most popular. It's not the, the only application of blockchain. We also have applications on blockchain with finance. Okay, where people can actually, control their assets, lend, and then actually borrow, with, on a peer-to-peer basis. And also have supply chain management. So blockchain technology can be used to, track, logistics and, stuff of that nature. And then we also have it in data storage. Yes, this is another, important use case of blockchain, basically to store data, because if you need a system where you actually want to store data and actually want to, maintain the integrity of this data, so that, it's actually true and credible, then blockchain can actually, work on that. And also have it in the health sector for keeping health records. Also having a lot of, segments, gaming, energy, property, and etc. So there are a lot of things, there are a lot of ways, there are a lot of use cases where, blockchain can be applied. Okay, basically anywhere I thought that, you need to store data, that has to be credible, but yet, accessible to everyone, decentralized without the need of a centralized body. Blockchain basically applies to that, because that's what it actually means. Okay. So now let's go further and let's talk about, now we've talked about the use cases, let's talk about the limitations. Okay. Now the limitations, blockchains, are immutable. That means, you can't change what is in there. So let's say you make a wrong transaction to someone, there's no, changing that transaction. Okay. It's pretty much, so far as been recorded on the blockchain, is pretty much it. So there's no going back on that particular transaction. That's why you have to be very, very careful. Another, limitation in terms of environmental, environmental factors, and their claims that, the blockchain technology, like let's say the Bitcoin network, actually consumes a lot of energy, because for people to, confirm these transactions, it requires energy, because this confirming this transaction basically means solving, very, very tough, mathematical problems. Okay, so we call it mining. The process of confirming transactions are called mining. So you might have been hearing about mining. Mining basically means validating, confirming these transactions before they are added to the block. So this process actually consumes energy, a lot of energy. So there's also another thing of responsibility. Okay, so since there's no central body to pack with this responsibility of holding, verifying, validating, maintaining, handling this data. Now the responsibility is on everybody. Okay, since we're the ones actually doing this process, we have to be responsible enough to handle this data and then our assets too. Okay, so there's also a thing with hacks and attacks. So if people are able to access your keys, it all boils down to responsibility anyway. If people are able to access your keys, yes, they can sign transactions on your behalf, and then they can also access your funds. So that's also a thing with hacks. Let's kind of wrap up what we've been talking about within the section. So blockchain, is a distributed ledger that stores information, and this distributed ledger has to be trustworthy. Okay, so it's decentralized, by the way. That means it has to be trustworthy while also being visible to everyone. And then there has to be system in place to confirm transactions because and to confirm the data, because once data is actually added on the blockchain, it cannot be removed nor modified. Okay, so now the concept of blockchain dates back to the 90s. Okay, it's not something that just started actually being here since the since the early 90s rather. And then today we've had applications advanced all the way to smart contracts, through the help of someone called Vitalik Buterin with his Ethereum blockchain technology. All right, so blockchain has many applications in many fields, finance, supply chain, health, and many more. It's a very good time to join the Web3 space so that you can start learning more about the blockchain. And to learn more about the blockchain technology, to engage in more blockchain related topics, make sure to join our Telegram channel at Binance Nigeria, and then follow us on Twitter at Binance Africa is verified. Make sure you're following the right account. Now on our Telegram channel, there are a lot of discussions related to cryptocurrency and the blockchain ecosystem going on there. I'm pretty sure is where you want to be. All right, guys, we've come to the end of this awesome video. Make sure to subscribe and then also share with your friends so they can learn about blockchain today. And then I'm going to see you in the next one, guys. Stay safe.